So we want to find the volume of the solid generated by revolving the region bounded by these graphs around the x-axis. So let's go ahead and draw these graphs and see what the bounded region looks like. So this is the graph for y equal to the square root of x. This is the line x equal to 3, and this is the line y equal to 0. And it's also the axis of revolution. And now what we want to do is take this shaded region right here, this bounded region right here, and revolve it around the x-axis. And this is what it would look like. And so we revolved it around the x-axis, and then this is the solid of revolution that we'll get. And now to get the volume of this solid of revolution, what we do is we're going to slice this into many disks. And so we'll take the bounded region and then we'll fill it up with rectangles. And if we take the first rectangle and we revolve it around the x-axis, then what we get is a disk or just a cylinder. And the same thing here. And so a typical disk would look like this. And so by take this rectangle and revolve it about the x-axis, then we'll get this disk. And the disk is nothing more than a cylinder. And so what we do is we find the volume of these disks and then add them up. And that will give us the approximated volume for the solid of revolution. Now we look at this disk right here. The disk has a radius from here to here, which is from the axis of revolution to the graph. And the graph is y equal to the square root of x. And the height of the disk, or the height of this cylinder, is the thickness of the disk, which is the distance, which is the width of the rectangle. And to get the volume of this disk, we just use the formula for the volume of the cylinder, which is pi times the radius squared times the height. The radius of the ith disk, we'll call it r of x sub I. That's the distance from the axis of revolution to the graph. The thickness of the disk, we'll call it delta x. So thickness, in this case, is the height of this cylinder right here. So the volume of this disk will be pi times the radius squared times the thickness. And so the volume of this solid will be the volumes of all the disks together. And so if we have n number of disks, if we slice this solid of revolutions into n number of disks, then we'll get the volume of the solid is approximately this. And in summation notation, then we get summation running from 1 to n. This is pi, this is the radius of the ith disk, and this is the thickness or the height of the ith disk. And so to get the exact volume, we allow n to run to infinity, meaning we'll slice this into an infinite number of disks. And this is what it would look like. So now we have 10 disks. Now we have 15 disks. It is 20 disks. It's 30 disks. And so on. And so that's how we get the volume of the solid of the revolution, is by slicing it into an infinite number of disks, and then find the volume of each disk and then add them up. And that will give us the volume of the solid of revolution. So now let's figure out how to find the exact volume of this solid of revolution. The radius of the disk will be the distance from the axis of revolution to the graph. In this case, the axis of revolution is this line right here, the line y equal to 0. And then the graph is the graph is this curve right here, which is the curve for y equal to the square root of x. And therefore the radius of this disk will be the square root of x minus 0. This is the line y equal to 0. This is the curve y equal to the square root of x. So the radius will be the curve minus the axis of revolution, or the square root of x minus 0, which is the square root of x. And our solid of revolution is from 0, x ranges from 0 to 3. And so the volume of the solid will be the integral from 0 to 3, square of the radius, and then the thickness of the disk is represented by dx. And this is the square root of x, that's the radius, and the square root of x squared is x. The integral, or the antiderivative of x, is x squared divided by 2, and then we evaluate. If we plug 3 and if we put 3 in here, 3 squared is 9, and then divided by 2. If we put 0 in here, we get 0 divided by 2, and so we end up with 4.5 pi, or about 14.137166925. And that's the volume of this solid of revolution.